Hello everybody, today we'll start with the new chapter in physics for standard 8th, that is energy. Right, so that is the fourth chapter in this book, that is Concise Physics. We have already done the earlier chapters, that is we already done the matter physics, the force and pressure we have done. Fine, so we'll continue with the chapter energy. Now, before we learn about energy, we will need to learn about work, and after that only then we can come to know about energy. This is because the energy is that particular physical quantity which is going to do a work. So, अगर मेरे पास energy है तो ही मैं काम कर सकता हूँ. It's a simple thing. But when I have got energy, only then I can do work. If I don't have energy, how can I do work? But if I am able to do work, first of all I have to say what is work. Okay. अगर मुझे मालूम ही नहीं कि काम होता क्या है और work होता क्या है, how do I know that energy can do a work or not? Okay, that's why we will first understand the concept of work. Okay, work. Now, in physics, work is very different. Okay, it is not something that अरे मैं ऑफिस में बैठ के काम कर रहा हूँ या मम्मी खाना पका रही है तो work done. No, that work done is maybe negligible for physics. Whereas in physics, even if I take this duster and put it from year to year, I am doing work. But अगर मैं एक जगह पे खड़ा अगर पूरा का पूरा ये लेक्चर दे रहा हूँ घंटों के लिए and I am not moving anything, then I am not doing any work. So physics में work is having a very different kind of a meaning. In physics, work is only done when there is a displacement of an object. मैं अगर ये दीवार को अगर मैं धक्का मारूं, पूरा 2 घंटा तक धक्का मार रहा हूँ, पसीने से पूरा लथपथ हो रहा हूँ, पर ये दीवार हिलने वाला नहीं है अगर, if this doesn't move even by a small centimeter or 1 mm also, I am not doing any work. भले मैं यहाँ पे पसीने से पूरा बर्बाद हो रहा हूँ. Okay, if I am sitting on a computer and doing some work for let's say 2 hours, 3 hours, just typing something, because in that thing I'm just moving my fingers. I'm not moving anything from one place to another. I'm not doing any work. So that's why in physics, when we say work, it is slightly different. Okay, so we need to understand the work or the principle of work in physics. In everyday life, all of us do some work. We do work when we play, when we go to school, when we go upstairs, when we pedal a cycle, when we lift a load, and so on. We always do some other work. Going upwards, going down, going to play. Every time we say some other work is done while doing some work during the whole day. In common language, we use the word work much vaguely. For example, if we push a wall, we say that the work is done by us. While reading the newspaper, we say that we are working. But actually, no work is done in those activities. If I keep on reading, if I keep on speaking like this for hours and hours and hours, physics doesn't consider this as work. Okay? Work, no, there is no work done. Okay? If I just be in one place and do some work without moving anything, then I am not doing any work. Okay? So that's why reading or any mental work, pushing something which is not moving at all, there is no work done. In physics, the word work has a special meaning. Okay, it has got a special meaning. What is it? Work is said to be done only when the body changes its position. Okay, so work is said to be done only when the body changes its position or moves on applying of a force on it. So if I move this, if I take this and I apply a force and this moves from here to here, Yes, work is done. Why? Because I applied a force and that force moved this, or there is a displacement of this body from here to here. So this displacement which is caused by the force, then it is said that I have done work. So work is done only when the body changes its position or moves, okay? Or moves on applying of force on it. No work is said to be done if there is no motion produced in the body even when a force acts on it. So if I apply so much amount of force on this particular wall that मैं उसको धक्का मार रहा हूँ कितना भी मार रहा हूँ, but there is no motion of that particular wall, then the work done is zero. So no work is said to be done if there is no motion, produced in the body even when a force is acted on it, or force is acts on it. Thus, we define force as work is said to be done if the force applied on the body moves it. If no motion takes place, no work is said to be done. So work is said to be done only when the force applied on a body makes the body move. Only when a force is applied and the body moves, then the work is said to be done. If there is no motion or there is no displacement, if no motion takes place, no work is done by the force. So that is how the force, that is how the work is supposed to be defined as. For example, a cyclist pedaling a cycle does work. A horse pulling a cart does work. An engine pulling a train does work. A coolie lifting a load does work. A boy going upstairs does work. A boy lifting a book does work. So they are given the examples wherein there is a movement of the body, there is a motion of the body, there has been a change in position of the body. Like for example, when the cyclist is pedaling, what is happening? The cycle is moving. It is moving from one place to another place. So movement is there. So work is done. Similarly, when a horse is pulling the cart, so horse is moving. So the cart is also moving. The movement of the cart from one place to another cart by the horse, the work is done. Similarly, engine is pulling a train. So the engine is moving along with that. The train is also being pulled. So the movement of the train along with the engine makes it the work to be done. A coolie is lifting a box and then he walks. So when he is lifting the box and he is walking from one place to another, the box is moving with him. Accordingly, the work is said to be done. A boy going upstairs, yes, and of course when a boy lifts something. So if I lift this duster, over here, yes, I am done work, because there is a displacement, there is a change in the position of the object due to the force applied by me. I applied a force to lift it up, and by that application of force, this body which was down, this duster which was down on the table has come up. So that's why we see that there is the application of force which caused the body to move, hence work is said to be done. When a crane picks up an accidental car and takes it to a workshop, we say that work is done. Yes, so crane जब ये एक्सीडेंट का कार रहेगा और को टोइंग वैन आता है, टोइंग वैन उसको उठा के लेके जाता है, तो yes, work is said to be done. In a playground, while playing football, when a boy hits the ball and runs towards the ball, we say that the work is done. Yes, because when he's hitting the ball travels in the direction of the force applied. Hence, we see that the work is done by the person, by the student against the ball. A boy climbs a stairs does work. So all these examples of work, very easy examples, but we'll just go by one. Work is also done by a force that the force applied on the body changes its size or shape. So this is the next kind of work. One case of the work was when you are having a particular kind of a body which is going to be moving when on application of force. But if the body is such that it is very soft, like okay, I'll take this handkerchief. So if I apply force, what has happened? The shape or size of that handkerchief has changed. So then I say that the work is done. So if the force applied on the body makes the body get converted into a different size or shape, then also the work is said to be done. For example, if a boy squeezes a toothpaste tube or gum tube or a rubber ball, he does work in changing the shape of the tube or the ball. Similarly, a boy does work in stretching the rubber string, in which the size of the string increases. So if I take a rubber band and stretch it, the size of this rubber band is increasing, yes, the work is said to be done. So we see a person does not work if there is no change in the position or no motion, even if force is applied. So when I take this duster, okay, I taken this duster, it is here only, I am not moving it, and I am trying to pull it or press it, and it is not changing in any shape, okay, then no work is done. So even if I applied the force, if the force is not causing any motion to take place, or if the force is not causing any change in the size or shape of the object, then no work is said to be done. So the examples for no work to be done are: a boy pushing a car or a heavy stone does no work if the car or the stone does not move. So if there is a car or a particular stone which is there, which is a person is when a boy or somebody is trying to push that thing and there is no movement of the car or the stone, if the car or the stone is just going to remain as it is over there, then no work is done. Though he may get tired. Yes, definitely, because when he's trying to push the car, he's definitely going to get tired because he's trying his very hard, he's applying a lot amount of force to overcome that particular, but unfortunately that doesn't move, and if it doesn't move, then no work is done. So yes, definitely he gets tired, but work done is zero. A person pushing against a wall also does no work, since he is not able to move the wall. So as I told you, if I am pushing this wall, the wall doesn't move, so no work done. Similarly, a coolie does no work while standing with a heavy load on his head, as there is no motion, although he may get tired holding it. But the coolie does work when he raises the heavy load to his head. So yes, when the coolie is taking the load and raising it and putting it on his head, at that time he is doing work, because the object moved from one level to other level. But the moment he has kept it on his head and then he is standing over there for 10-15 minutes because he is waiting for somebody, at that time no doubt he is getting tired because the load of that particular body is there on his head, and so he is getting tired. But work done by him is zero, because there is no motion of that particular object on his head. So that's why, since there is no motion of the object, that's why the work done by the coolie will be zero, as there is no motion of the object. So yes, when he is standing with the luggage on his head, no motion, then no work. But if when he is lifting that load and putting it on his head, yes, at that time the work is done. Thus, following two conditions must be fulfilled for the work to be done. So what are the conditions for the work to be done? First one, force to be applied. Okay. First one, a force must act on a body. Okay, there has to be a force which is acting on the body. The work can be done only when a force is applied on a body. If the force is not applied, there cannot be any work done. So first thing is, the force must be acting on a body. The first thing is the work के लिए सबसे पहले what is necessary? The first thing necessary is the force. Force is the first thing which is necessary for the work to take place. Second, force must produce change in position, that is motion or change in size or shape. The next thing what is required for the work to be done is change in position, size or shape. Okay, change in the position, size or shape of a body is required for the work to be done. So if the force is applied but there is no change in the position, no change in the size or no change in the shape of the body, then the work done by that person is zero, even if the force is present. even the force is present, but if that force is not producing any motion or change in position or change in size or shape of the body, then no work is done. Okay, so for the work to be done, both these things, so both the things, so even if there is a change in position but it was not, no force was there, okay, if there is change in position but no force, so for example, if actually something moved because of gravity, but if I say this, I'm just releasing it. So did I apply any force? I didn't apply any force. It was due to gravity that this fall down. So what is the work done by me? Zero, because I did not apply a force. So if the presence of force was not there, work done by me is zero. Similarly, change position नहीं है, size का shape changes shape or changes size नहीं है, no work done. So work is done only under two conditions: force applied, second, change in position or size or shape of the body. Hence we have the factors affecting the amount of work done. So we can easily find out the factors on which the amount of work done is dependent on. First one, experimentally it is found that the amount of work done by a force depends on the following two factors. First, magnitude of force applied, and second, distance moved by the body in the direction of the force. So what we see is, the first thing is over here, that work done will be equal to, over here will be proportional to, we'll say, proportional to the magnitude of the force applied. So that is the magnitude. Okay, 10 Newton, 5 Newton, what is the force applied? So that particular magnitude of the force which is going to be applied is what is required for the work to be done. And secondly, the distance moved, the next kind of proportionality, the next thing which is related to, so the factor, the first factor is this one. Okay, I'll not write it this way, you get confused. So I just write in the form of words that factors for work are, first is magnitude of force. What do you mean by magnitude force? The numerical value of force. Okay, कितना न्यूटन फोर्स अप्लाई किया है, ओके 5 न्यूटन, 10 न्यूटन, 20 न्यूटन, 100 न्यूटन, नॉट ओनली न्यूटन, केजीएफ में भी चलेगा. सो whatever is the amount of force applied, that is the magnitude of force. And secondly is, what is the displacement or the change in position? That's why we call it as a distance moved by body, by the force. Distance moved by the body, yeah, by the body in the direction of force. Okay, so distance moved by the body in the direction of the force. I apply the force upwards, and if the body is going to go downward, like for example एक गाड़ी स्लोप पे खड़ी है और मैं उसको धक्का मारने के ट्राई करके ऊपर जाए, पर उसके पहले गाड़ी पीछे आती है. ओके, ये एक स्लोप है, ये स्लोप में ये गाड़ी है. दिस इज द कार व्हिच इज ओवर हियर. Okay, we'll see this is the car, and I'm pushing this car from the behind. Now when I'm trying to push this thing, if it is, instead of going this way, it starts coming backwards, then what is the work done by me? Nothing, negative in fact. Okay, Q, okay, the motion, the distance moved by body in the direction of the force. Did I apply the force downwards? No, I am applying the force upwards. But what is the position of the car? The car is going downwards, because the car is not moving in the direction of the force. There is a motion in the car. We always studied that force होना चाहिए और motion होना चाहिए. यहाँ पे force भी है, motion भी है. But what is happening? The force and the motion are not in the same direction. Force is upwards, but the motion is downwards. So when the direction of the force and the direction of the motion is not the same, then also work is not said to be done. That's why the factor affecting the work will be distance moved by body in the direction of the force. वही डायरेक्शन में मूवमेंट होना चाहिए. अगर वही डायरेक्शन में मूवमेंट है तभी ही काम हुआ है. दैट इज द वर्क डन इज ओनली व्हेन द डायरेक्शन ऑफ मोशन इज द डायरेक्शन ऑफ द एप्लीकेशन ऑफ द force. Got it? Good. Next, so we see here in detail what is the explanation towards this thing. So dependence of amount of work done by the magnitude of the force applied on the body. Work is more if the force applied on the applied to move the body is more. So yes, more the force applied, more will be the work done. Simple example. Cricket खेल रहे हो या फुटबॉल खेल रहे हो, या मैंने अगर किक स्लोली मारा तो बॉल कैसे जाएगा? स्लोली जाएगा, बहुत दूर तक नहीं जाएगा, शॉर्ट डिस्टेंस के लिए जाएगा. और मैं उसको जोर से किक करता हूं तो फोर्स इज मोर. इफ द फोर्स इज मोर, द डिस्टेंस व्हाट इज गोइंग टू ट्रैवल और द वर्क व्हाट विल बी डन विल बी मोर. सो मोर द फोर्स, मोर विल बी द work done. So that's why magnitude of force directly related. More the force, more the work done. More work is done by us if we lift a bucket full of water from the ground floor to the first floor than if we lift an empty bucket to the same height. The reason is that when we apply a greater force to lift we have to apply a greater force to lift the bucket full of water than to lift the empty bucket. Yeah, if I want to lift the empty bucket, it's very easy. I can lift it very easily. So the amount of force required to lift that particular bucket will be much less as compared to the force required to lift the filled bucket. So automatically the force required will be more if the it is heavier object, or we can say that work done will be directly related. So work done will, of course, will be more in a filled bucket because filled bucket का वजन ज़्यादा है, तो इसलिए work done will be more. So more work is done in lifting a bucket which is full rather than lifting the bucket which is empty. Dependence of work, amount of work done on the distance moved by the body in the direction of force. Work done is more if the distance moved by the body is in the direction of the force is more. So if the distance moved by the body, if I am having it here, if I am applying a force and it is direction of the movement is this one, so अगर ये यहाँ से यहाँ तक गया तो work done is smaller. If it go from here to here, the work done is more. So more the distance is travels by the force, the more is the work done. So more the distance, more the work done. So more the distance moved by the body in the direction of the force, more will be the work done. For example, work is done by us if we lift the bucket of water from the ground floor to the second floor. Then if we lift the same bucket from the ground floor to the first floor. So if I am lifting the bucket from the ground floor to the first floor, I am doing lesser work. But if I am lifting the bucket from the ground floor to the second floor, the work done by me will be much greater. So this is how we can the factors for which are affecting the work done by the body. So now we define work. So now we understood the different work, and that's why we have to define work. So let's define it. We define the work done as follows. The work done by a force on a body is equal to the product of force applied and the distance moved by the body in the direction of the force. So yes, we are directly, what we are doing is, suppose इसको हम लोग ने F ले लिया और इसको हम लोग ने D ले लिया था, the distance, then we can directly say that the work is nothing but the product of the force into the distance moved by the body in the direction of the force. So that's why we can say that W is equal to F into D. So let's define it once again. Work done by a force on a body, the work done by a force on a body is equal to the product of the force applied and the distance moved by the body in the direction of the force. Okay, what is it? It is the product of the work done on a body, the work done by a force on a body is equal to the product of the force applied and the distance moved by the body in the direction of the force. That is, work done is equal to force into distance moved by the body in the direction of the force. Hence in figure 4.7, let a force F be applied on a body which moves it by from the position A to position B by a distance D in the direction of force. Then the work done by the force on the body is W is equal to F into D. So when we are given that a body which is like this, there is one body which is at position A, it is going to be moved from here to here, which is position B, and for that if we are applying the force F and the distance it needs to move over here from A to B is D, then W is equal to F into D. Okay, W is nothing but force into distance moved by the body. Now obviously if the force acts on a body and the body does not move, so if D is 0, work is 0. Simple. Force not applied, then work is 0, right? So if the force acts on a body and the body does not move, no work is done. W is 0 if D is 0. Now we do see the units of work. So the units of work are, we have read that the SI unit of force is Newton. So we very well know that the SI, so we have W is equal to F into D. The SI unit of force is Newton and that of distance is meter. So therefore the SI unit of work is Newton meter, which is given a new name that is equal to Joule. Okay, given as the letter J. So 1 Joule is equal to 1 Newton meter. Okay, so we know SI unit of force is Newton and that of distance is meter, and the SI unit of work is Newton meter or Joule. The unit Joule has been named after the name of the scientist James Prescott Joule. Definition of Joule: since 1 Joule is equal to 1 Newton per 1 meter, so 1 Newton into 1 meter is called as 1 Joule. Okay, 1 Newton into 1 meter is called as 1 Joule, and we can define 1 Joule. So we'll define 1 Joule in the similar manner as what we define work. So we'll say 1 Joule of work is said to be done. So, okay, 1 Joule of work is said to be done if 1 Newton of force when acting on a body moves it by 1 meter in the direction of the force. Okay, so when 1 Newton of force acting on a body is making the body move by 1 meter in the direction of the force, then the work done by the body is equal to 1 Joule. Okay, 1 Joule of work is said to be done when a force of 1 Newton is displayed or is causing a motion of the moving the body by 1 meter in the direction of the force. So that is 1 Joule. 1 Joule of work is said to be done if 1 Newton force when acting on a body moves it by 1 meter in the direction of force. A bigger unit of work is kilojoule, that is kJ, where 1 kJ is equal to, so 1 kilojoule is equal to 1000 joule. 1000 joule is 1 kilojoule. If we measure the force in kgf and the distance in meter, the unit will be kgf meter. So if instead of Newton, if I use it in kgf, then the unit will be as equal to 1 kgf meter. Okay, so that is provided we are taking the force in kgf and not in Newton. Since 1 kgf is equal to 9.8 Newton, so 1 kgf meter is 9.8 Newton into meter, or we can say that 1 kgf meter is equal to 9.8 joule. Okay, because of 9.8 being the gravitational force, so 1 Newton is equal to 9.8 1 kgf is equal to 9.8 Newton. Therefore 1 kgf को अगर convert करना तो it will be 9.8 Newton. So 9.8 into meter, that will be 9.8 joule. Assuming that the force of gravity on Earth is of mass 1 kg is 9.8 Newton. So this was about the work. They also given one did you know? So let's see that. In chapter 3 you have read that the unit of moment of force is Newton meter. So yeah, you should not get confused over here. So that's why you given that the moment of force is Newton meter. But we do not write it as joule. only from work energy, the product Newton meter is given as joule. So do not consider that ये भी Newton meter है तो ये joule है, तो why not moment of force be also Newton meter? So no, that moment of force will always be Newton meter only, it cannot be joule, whereas this will always be in joule and not in this way. This is the distinction, this is to distinguish movement of force with from the work or energy. The work done by a force is zero if the body moves in a direction perpendicular to the direction of the force. For example, when a stone is tied to the end of the string, is whirled in a horizontal circular path, the stone, the motion of the stone is always normal to the force of tension in the string as shown. Therefore, the work done by the force of tension on the stone is zero. Similarly, in motion of earth around the sun, the force of attraction on earth by the sun is always normal to the direction of the motion of the earth. So no work is done by the gravitational force of the sun or the earth. So this is basically that if I take a ball, if I take a string and a ball and I do it like this, at that time my force is there, motion is also there, but the direction of the motion and the direction of the force are perpendicular to each other. Why is it so? Because when I'm taking at any particular point, let's see this one. If I got this point, this is the application of force, and this is so the string is over here. String is like this, whereas the direction of the motion is tangential always. So this is perpendicular. So whenever the force and the motion are normal, that is 90 degree or perpendicular, there are different words for the same thing. Normal is 90 degrees, perpendicular is 90 degrees. So when the force and the motion both are perpendicular to each other, then the work done will be zero. Okay, remember this thing, that work done. Now this we will learn later on in the 10th standard why it is zero. This is because of a new formula that will be coming up, where you will be requiring something from the 9th standard chapter in mathematics, that is trigonometry. So right now you can just forget that part. It is just as such also is only in a did you know part. So you just need to know one thing, and that is when anything is moving in a circular direction, circular motion, like the revolving of the earth around the sun or the moon around the earth, तो वो जो भी motions है, circular motions है, in that case the work done will be zero because the direction of motion is perpendicular to the direction of the force applied. So that's why it is not going to be calculated anyway, it will be just zero. So that was about the work. In the next video we will do the energy part.